Hi, welcome to Why Projects Succeed. We're going to talk a little bit about the history of Android and some of the elements that led to Android's sort of strange success so far in the world and the ecosystem, and what lessons we can apply from Android's rise to other software projects that you may be familiar with or may be working on at this time. I'm Chet Haase. I'm on the Android graphics team.
And I'm Romain on the Android Toolkit team.
And let's start with information about the book. So a lot of the stuff that we're going to talk about in this presentation is from a book called Android's The Team That Built the Android Operating System. It's available in paperback, in ebook, and in audiobook. It provides some amount of this history that we're going to go through, as well as analysis of why this project actually worked, stepping back and saying, okay, what were the elements in the development of Android that contributed to it still being here today? I should point out that nobody's making money off this book except some charities. We're donating all the profits from the book to tech-related charities.
And for the record, I'm very uncomfortable recording this big ad for your book.
I'm not. I think it worked for me.
I figured you were.
It's good.
So like Chet said, Android was a huge success. Currently, we are at Android 13. I think it's API level 33. Am I getting that right? Sure. I'm getting confused in my numbers. Yeah. We have this brand new UI that came from Android 12 called Material U. So huge departure from the previous versions of Android. We've had many changes of UIs over the years. So the OS has been evolving constantly. And so has the hardware. So here you have a Pixel 6. It's our latest and greatest at the time we're recording this talk. But I'm sure there will be more devices coming soon. And now we have about 3 billion active devices in the world. That's devices that are actively being used today. So of course, we didn't get there in one day. It took, 15 years? And in this talk, we want to explore how did we get here? Where did Android come from? And how did we go from a very tiny team to this massive success that, has like half of the population using it as their primary operating system? So something that some of you, or many of you might not know, is that Android started for cameras. It was an operating system designed for digital cameras. So back then, DSLRs were starting to be good, not amazing, but good. It was still early. So it was, in the early 2000s. So in 2003, Andy Rubin and Chris White created this new company called PhotoFarm. And they wanted to build an open source platform for digital cameras. They wanted to build the operating system, but also an SDK, a way to build applications, a way to make it easy to build your own camera and to build, a custom UI or custom processing for the photos that you take. So Andy and Chris had prior experience building hardware. They worked at Danger. So Danger built the T-Mobile Sidekick, a very popular device in the US. And I think it was one of the first devices that would give you like full internet access. It was one of those first messaging devices. And actually, if you watched movies from this era, you may have noticed those flip phones that a lot of cool people were using back then. I was not one of them.
Cult classic smartphone, I think we can call it.
Yes.
So they were interested in building cameras, but nobody else was really interested in it. In particular, they took this story around to VCs in the area and they said, we have this great idea for making this platform. And the VCs responded that we don't really think it's a great idea for making money, which it turns out is really the priority of venture capitalists. So they get zero interest from anybody for that. At the same time, a couple of people that Andy had known from his Danger days, Rich Miner and Nick Sears, talked to him and said, hey, that camera idea, it's a really great idea. We're not interested, but if you are interested in smartphones, then maybe you can come talk to us. So Andy wasn't interested in smartphones because he'd already done that with Danger. He figured he was done with that part of his life, but he surfaced the idea at a couple of these VC meetings and the ears in the room perked up. And he thought, okay, well, maybe we can do this instead.
So it was an interesting pivot because the idea was still to build an open source platform, but not for cameras, for phones. And here you can see a couple slides from the pitch deck that Andy and the rest of the team were using when they were meeting with venture capitalists. And you can see some of the arguments in favor of building this open source platform. Smartphones were getting popular. Obviously, a lot of people already had phones, mobile phones, but smartphones were getting more capable. The hardware was getting really good. It was approaching the capabilities of the desktop PCs of the time. And the problem was that in the market, you could maybe license Windows or you could use a Linux stack. But if you use the Linux stack, you still had to integrate everything yourself. You didn't really have an app platform. You had to build that yourself. And the idea here was to give you something that was ready to go, ready to use, and that would provide compatibility for app developers across multiple form factors. And around the time that they started pitching this idea to various VCs, there was a small company called Google that had recently IPO'd and was getting some success with things like a search engine or Gmail. And they wanted to talk to the team. So they got 2 offers from VCs, or at least Andy's team got 2 offers from VCs, but Google offered to acquire them instead. Instead of funding them, Google said, hey, how about you join us and you'll build the operating system as part of Google, and you'll build the team as part of Google.
So details. They figured out what they needed to make that work. And then the acquisition went through. And the acquisition meant, I should take a step back here. I saw people talking online about, how Android came to be. And they said, well, Google acquired this company and then they shipped the phone and the platform they had. And that wasn't it at all.
Not quite.
No. What they actually acquired was an idea and 8 people working on the project. So there was an administrative assistant, there were the 4 founders, and there were 3 people that were actually writing code for the product. And most importantly, there was that vision. There was this idea of what they wanted to achieve and how they were going to achieve it. And the technology that they developed at the time was a demo. That was it. So this is it. This is a desktop version. It's basically some emulator running on the desktop showing you what one of these future phones might look like. Note, it doesn't look like any Android phone we've ever shipped, but it was the idea of these connected services and what smartphones could do in the future. So there was a person on the team that joined later, Wei Huang, who said, he took a look at the code that the company came in with, and he said, how did you acquire this company for all this money for 3,000 lines of JavaScript? Because that's basically what it was. It was a JavaScript demo showing what could be, but when they actually arrived at Android, they needed to reboot everything and actually start working on what would be the product.
So after the acquisition, that's when the real work started. Of course, there was a world of difference between that demo and what became Android 1.0. So before the team could reach 1.0, they had to build a few things. First, they needed a kernel, so they took the Linux kernel, but then they needed drivers. And the team was pretty small, but they had to write their own drivers for a number of things. For instance, the binder system that's used for inter-process communications is part of the kernel, and the team had to build a driver for that.
They needed a language. In fact, they started out with the idea of having 3 languages. So JavaScript was obviously going to be there because that's where the product started with that demo, right? And JavaScript, obviously popular language with a lot of developers. Sure, we'll do JavaScript. A lot of the people that joined the team early on were embedded programmers, very low level. Obviously, we need C and C++ support because that is where real embedded systems are built. We have every control over every piece of the platform that we need. Obviously, we're going to do that. And then the third language idea was the Java programming language, which was popular across the developer ecosystem at the time. It's kind of good to use a language that developers know, sort of lower the barrier of entry when they're learning a new system with new APIs, which they were going to need to do with Android. At the end of 2005, so they got acquired July of 2005. By the end of that year, people on the team realized maybe having 15 people work on everything, including support for 3 languages, was a little bit much. So there was a decision coming down from on top. You know what? Java programming language is going to be the SDK language that we use. So let's lock in on Java, and then we're going to need this runtime that's able to run the bytecode that we compile.
Language and the runtimes are not enough to build applications, or at least not if you want it to be easy to write applications. So you need a number of utilities for that. So the team was busy building a full application framework that contained a UI toolkit, a graphics layer, media capabilities to play back video and audio. And of course, there's a whole system UI layer. That's the user interface. That's your notifications, your lock screen, your launcher. So again, the whole team, the team was responsible for all those different layers that were sitting on top of the kernel and runtime.
It's important to note too that with all of those things came APIs. The goal from the beginning was we want public APIs so that people can write powerful applications for this platform to do whatever it is they need to do. We're going to start out with some of the built-in applications that Google has that are going to be popular and useful in these kinds of phones, but we expect other people to write to these public APIs as well. So they started out with those Google applications, things like Gmail and contacts and maps, of course. That was going to sort of form the foundation that the phone might ship with, but then they also wanted people on the outside to be able to write these applications. There was something else I was going to talk about.
Building the applications were built by the Android team. So even the Gmail app, for instance, wasn't built by the Gmail team that was in charge of the J2ME version for regular mobile phones or for the web version. So it was great for the Android team. I mean, it was a lot of extra work, but it was great because it was a good way for us to figure out what APIs do we need to build in our framework, in our UI toolkit to make it possible to build such applications. And actually several members of the team, like for instance, including myself, worked on some of those apps, which gave us, experience building applications so we could refine our APIs. Even if we have a few regrets about some of the APIs, could have been a lot worse if we had not been building the applications ourselves.
I like the positive spin that you put on that, like, we got to create the APIs that we needed and we got to work on both. Also, the team did not have a choice because if you think about it at the time, Android was potentially years away from shipping anything that anybody in the real world would use. And all of these product teams, Gmail, Calendar, Contacts, Maps, they had real users throughout the world already. They had enough work to do, thank you very much. So they had zero interest in building for a platform with, by definition, zero users. Why would they do that? And so the Android team really had to take on this work themselves because nobody else was doing it for them.
And to build those applications, we also needed to build services as part of the system. So some of the services were data services, how to access all the contacts, the calendar, for instance. But there were also services that were more core to the operating system, for instance, the window manager, the activity manager, all the things that really power the user experience on the device.
The update system and the check-in system as well, so that we could roll out updates and figure out how things were working in the ecosystem.
And there were several times where we made sure that the update system would work so that when you turned on your phone, we could send you the fixes for the few bugs that were left.
And then Android Market was one of those things we needed to enable as well, a place where developers could upload applications and then users could download those applications. This was the plan from the beginning. As I said, they weren't just building the Google applications for the phone. They expected external developers to also build their own applications, and they needed a place for those applications to actually live and be downloadable from.
And just to be clear, that's what we call the Play Store nowadays.
Yes.
Last but not least, we need an SDK. So all the tools that you need to build your applications and to test them. So this included a plugin for the Eclipse IDE. So the plugin would give you access to all the tools needed to build high quality applications like a profiler, for instance, or the emulator to be able to run your application without access to a device, or simply to test your application in different hardware configurations. The SDK also came with documentation, ADB, that's how you talk to the device, and so on. You can actually find all of our SDKs still on developer.android.com. The link is a little hard to find, but if you do find it, you'll be able to download the very first SDKs that predate Android 1.0. And I think they're super small. They're like 40 or 50 megs, including the system image of the emulator. So you can imagine we added a few features since then.
All right, so in the middle of that 1 to 1.0, the iPhone launched. In January of 2007, Apple announced that they had this nice idea for a smartphone called the iPhone. And then in June of that same year, the iPhone was released.
So it's interesting because I joined the team in March or April of that year. And when I was talking to the team to maybe join them, they were already telling me and showing me some hardware with touchscreens. So touchscreens were already something that was on the mind of the Android team, and they knew it was something they would have to do even without the iPhone announcement and launch.
Right. So there was a change, though, where touchscreens, it was not something that was, invented or new on the iPhone. It existed on various devices for a while, right? And in fact, it had been on other smartphones. But the combination of whatever it was, timing, marketing, the way it was all put together, all of a sudden touchscreen capability became kind of a checkbox item for something that wanted to compete in the smartphone market. And that caused a change to the the priority of things internally on the team, where before the original plan was, okay, we've got one device that we're going to ship with 1.0, and we're going to codename that one sooner because it's going to come out sooner. And then we have this other device that will have touchscreen capabilities that will be codenamed the Dream device, and that was going to come out later, not sooner, but later. And what happened after the iPhone was announced was the team said, okay, well, we can't come out with the sooner device because that basically competes with Blackberries. We're not aiming to compete with Blackberries. We want to compete with full-on smartphones. So what we need to do is not do that sooner device anymore, but prioritize and get the Dream device out as soon as we can.
I've always been bummed that it was called the Dream and not the Later.
Yeah.
That would have made so much sense.
Would have been good. Actually, the reason it's called the Dream was apparently there was a meeting in some partner a couple of years before where the company had said, so who's going to work on this operating system? Thinking, okay, this team of hundreds. And the answer was Brian. Brian Sweatland is. He's got the kernel working already. He's on the problem. And the company's response was, that's ridiculous. What are you dreaming of that you think this is going to work? And that's where the Dream device name came from. All right. So then in October of that same year, so iPhone announced January, launch released in June. And then in October, finally, the world was able to, and Google was able to understand what the team had been working on. It was very secret up to that point. But in October, the SDK was first released, the 0.3 M3 release, milestone 3, and now developers could actually play with the early APIs and the emulators, which, as Romain said, you can still get online if you want to do that.
I think it's important to emphasize that the SDK came out with no hardware or device to play with. You just had the emulator. And finally, the team made it. A year later, we shipped Android 1.0. It came out on the T-Mobile G1 device, codenamed Dream. You can see a picture of it on screen right now. It was a beautiful device that was a touch device and also a hardware keyboard-based device. You could flip open the screen and get access to the keyboard.
And a trackball and D-pad and like all the inputs.
Just a trackball. There was no D-pad. But it was a great first device. It had a lot of sensors that not many phones had before or didn't have all the sensors. I think there was a barometer, a gyroscope, a compass, GPS, a GPU, a trackball, LEDs, everything you can think of that you could dream of was part of that phone. And more importantly, we also open sourced the entire stack. So you could buy a T-Mobile G1 in a store. You could go download the source code of AOSP. You had instructions on how to compile the source code, and you could flash your phone yourself and make modifications to the operating system. And obviously, you could also sideload applications. And finally, app developers were able to run applications on the real hardware however they wanted.
All right, so phone launches and obviously success, right? So let's take a look at the graph of what was actually going on at the time. So if you look at the graph, there's 2008, we launched 1.0, sort of 3/4 through that, not much happening. And then into 2009, you see that green line at the very bottom, and it just kind of stays flat at the bottom the entire time. That's comparing Android to everything else going on in the ecosystem. There was successful Windows phones out there. The iPhone had come out. It was doing pretty well. Nokia was way on top. They had like 70% market share, especially including feature phones. Like everything else was doing very well, thank you very much. And then Android was just kind of petering along down at the bottom. And then in 2010, we saw the following thing happen where all of a sudden people started buying devices and the line just went up from there. So there's a couple of things going on in there. One is the Droid came out at the end of 2009. This was what the team considers the first commercial success of Android, where the combination of the devices, the capabilities, the platform, the recognition of what was going on in the system, as well as marketing. It turns out marketing and advertising actually works, and consumers started picking up those devices in real numbers. And on top of that, as that was coming out the first few months, manufacturers across the world had been spooling up their own devices, in back rooms somewhere, and those devices started coming out throughout the rest of the world. And that's really where what we call the hockey stick started, where the slope just went up and it just kept going.
Because if you think about the timeline, the software for Android came out at the end of 2008, and here we're talking about early 2010.
Yep.
So that's about a year and a half between when the software was finally available and when the sales took off. In a year and a half, that's about the time it took to come up with the new hardware, put the software, customize it for the hardware that was coming out, and finally releasing it to the public.
So there's another interesting graph where all of that stuff was about smartphones, but you can also look at feature phones. Feature phones at the time that Android came out were sort of the default choice of everybody. If you didn't have the money or the desire for this, expensive thing, this expensive device, nor did you want a high monthly fee for all the data charges, you just got a feature phone, right? It would give you phone calls, it would give you messaging, and that's it. And that's all that most people wanted or felt that they could afford. But fast forward into 2012, 2013, not only did Android surpass all of the smartphone makers in the world in terms of monthly regular sales, but also feature phones, because the combination of the hardware, the capabilities, all the applications you could get there, everything you could do on these computing devices in your pocket, plus the availability of all these devices across the world meant that the prices came down both on the devices themselves as well as the carrier plans. And all of a sudden, this became the default choice for everybody that just needed a phone, no matter what they were looking for.
So I think we made it clear Android was and is successful. So the big question we want to answer is, why did it work? So there was this tiny team that was acquired by Google, right, with just an idea and a JavaScript demo, and then this rush to Android 1.0. And the competition, you mentioned some of them, there was Nokia, RIM, the company behind BlackBerry, or Microsoft, had most of the market share out there. And they had operating system that they had been working on for years. So they had a full ecosystem. They had the SDKs, they had the applications. So what happened? How did we do it? We think. So first of all, the team itself, right? It was a very small team. I think when I joined, you can see on the graph the evolution of the size of the team. There were maybe 40 engineers when I joined the team. And when we shipped Android 1.0, maybe like 100, something like that. But very importantly, amongst all those people on the team, most of them, if not all of them, actually I felt a bit left out, were experts in the field, right? They had worked on operating systems before. So many of them had worked together. You can see on the slide, there's the green line and the dotted line. The dotted line is people who came from Danger, B, and Web TV. So 3 companies that had been doing embedded devices or mobile devices, and they had worked together or worked on problems that were similar to what we are doing. And some of them, had known successes, some of them had known failures. So they had good ideas on what to do, but more importantly, they had good ideas on what not to do. And they were also able to not really predict the future, but they had a good idea of where mobile phones were going, right? For instance, we knew that the density of the displays was going to increase by a lot. So I remember when we shipped Android 1.0, a lot of developers were confused with the need of using layouts and the DPI units, those device-independent pixels. But the team knew it was necessary because very soon, very quickly, we would have devices with different screen sizes, with different density of pixels. And without those capabilities in the platform, it would become difficult for the apps to remain compatible. And other things like the GPU, for instance, I think you put that really well in the book, where the folks working on the graphics pipeline knew that GPUs, it was still early for mobile phones, but it would become very important. So they made sure to put GPUs at the core of the design for the platform.
One of the dynamics that was clear at the time was the team was really small, but they were also essentially kept siloed from the rest of the company. So whenever you hear about an acquisition in a company, a lot of times they will say, oh, we're going to run it separately and it's going to be its own startup. It's never really true, right? The team gets incorporated. They try to, inculcate the team with the culture of the existing company, and, people move around. The founders usually take a check and leave, and everybody gets spread around, and maybe that product doesn't even ship again once they're in the company. This is just the reality of integrating unlike things together and hoping that things work. In Android's case, it really was run as a separate team. The leadership of Android dealt with the rest of Google, and the paychecks had to come from somewhere. But the people on the team were really focused heads down. Everything they were working on was completely unlike anything else going on at Google. Everybody else at Google was working on back-end infrastructure, JavaScript, front-end client stuff, networking. It had nothing to do with what Android needed, which was we're building an OS and we're shipping it on other manufacturers' devices. We're going to be working with them. We're building drivers, and we have these deadly timelines that we have to meet, right? So if that manufacturer is committing an assembly line, you have to hit that deadline no matter what. And so you can't be in some, long-running design meeting to come up with the perfect API and the solution like that. Maybe that's great for the long term, but actually it is more important for you to hit a deadline. And so you just run as fast as you can. So what happened was they siloed the team off, and it ended up being really important to the team because then everybody was really focused on what they needed to do. And they would run as fast and as hard as they could because that's what they were doing. They were not Google engineers working on a Google technology. They were Android engineers working on shipping Android, period. So that was one of the dynamics I think that was the most clear to me was by running it as a separate organization internally, they really built their own kind of culture within Android that had really essentially very little to do with the rest of Google, at least for that limited time until the team got past 1.0.
And I think Ficus put it really well. So this is a quote from Ficus Kirkpatrick, who was one of the early members of the Android team. So the currency of Android was working hard. Putting in, should I say that on video? Putting in a lot of hours was very valuable culturally. And that is true. Like the team worked incredibly hard to hit 1.0 because there were a lot of external forces. There were a lot of constraints. When you want to build a phone and when you want to sell that phone, at some volume, there are certain times of the year that are better for sales. Typically, we're going to have Black Friday in the US or the holidays at the end of the year. And there was no way we could miss those deadlines because that would have spelled doom for the project. So we tried to cut as much as we could, as many features as we could, but at some point there's nothing left you can cut. So what else can you do is work more. I'm glad we're done with that, but that's what we did for Android 1.0.
I think Chuki, one of the people on the team, Chuki Chan, put it that she learned on Android that Christmas actually happens in August because that was the deadline you had to hit. Because for manufacturers' devices to come out for the holiday season, which is obviously a really big time for manufacturers in this kind of device, you really needed the software to be done in August. So that was the date that the team always ran toward really hard and fast.
And people don't buy their presents, on December 25th. They buy them before that. So they need to be in store before that.
So there were a few categories of things that we think contributed to the success that Android has had so far. First of all was the early tech that they came up with. So there are obviously a lot of features that are shared between phones. Certainly today they're more alike than dissimilar. But back then there were things, they needed to be able to make phone calls and messages and stuff like that. But there were a few distinguishing features and a few things that were very unique about Android at the time. One was the ability to future-proof it. Romain spoke to some of that, being able to come out with layouts and ideas around densities that would actually enable applications to continue looking good even as different form factors came out. The idea of notifications, the sensitivity on the team to the fact that there were going to be these little micro applications that users would ping pong between, as opposed to monolithic applications that you would live your lives in, was important because you needed the ability to then get back and forth between these things with the multitasking the OS enabled, and to get notifications so you could find out what happened in these other applications.
And specifically, I would say push notifications. I remember when I started using a T-Mobile G1, I would get my email notification on my phone faster than on my computer. So usually I would feel my phone vibrate in my pocket, and then I could switch back to my Gmail tab and finally see the email. That was pretty cool.
Security was obviously important from day one. It's even more and more important as we go on in time. User privacy, user data, protection of all that, highly important. They built it in at a fundamental level from the beginning. So if you think about the way that operating systems work, there's this concept of user IDs. I have a user ID on that OS. And typically in a desktop, if I install an application, that application has the same rights as I do because I installed it. In Android, they flipped it and said, no, it's not the user that has these rights. It's the application that has these rights. So they installed every application with its own virtual user ID. That meant that if I installed application A and application B, they would run sandbox. They didn't have the rights to get to each other's data because they weren't running as me. Instead, they were running as themselves and wholly separate from everything else on the system.
The dev tools were also a huge part of making Android successful. So we mentioned the choice of the language. We used the Java programming language. There were millions of existing Java programmers. It was taught at universities and schools all around the world. It had well-known APIs, lots of documentation. And importantly, you got access to a lot of free tools. I mentioned Eclipse. It is
Eclipse.
Yeah, it is an open source and free IDE, which was a big deal because between our SDK, the emulator, and an IDE like Eclipse, you could get started writing applications on Android for free. It was, about like lowering the barrier of entry for everyone to be able to participate in that ecosystem. And same thing with the Android market. We made it as easy as we could to let you publish your application. At first, you could only publish free applications. When did we add the
I think it was 1.1. It was the next
1.1, yes. Yeah, we were a little late, I think, probably on the backend side.
Free is easy. Charging things? Ooh,
yes,
that's hard.
But at least it was fairly easy for anyone to be able to publish their application on Android market and make it accessible to any Android user.
The business decisions were important as well. So probably the most significant one was open source. If you think about a company that offers their own platform to other companies, let's say Microsoft at the time, right? They license their platform. Well, that means that the companies that license it, need to pay a fee. Fair enough, they did the work. They should get money for the work that they did. But that does need to factor into it, okay, how much money are they going to make on the devices and how much are they paying to license the operating system? But also they need to know where that other company is going to be in the future. If a startup comes to them and says, hey, license our platform, and then that manufacturer has to go to a lot of effort to port their stuff onto it, they kind of want to know that the startup is going to be there the next year. They're not going to change strategy and direction, and that they're not going to come out with something for the platform that doesn't make sense for them. With open source, it did not matter, right? They didn't need to buy into Google's business plan or Android's business plan. They could just go get the code and do what they needed to with it, which was a huge change and a huge advantage for building an ecosystem as opposed to selling a Google phone that was specific to Google's needs. There were other important business aspects like working with partners, the ability to work within Google and therefore other companies like chip manufacturers saying, hey, it's a big company. Maybe we would be interested in giving you development boards or working with you more than they might be with, say, a startup the size of early Android pre-Google. And there was compatibility. This was huge from day one. The team going out and convincing everybody that they really wanted to run a compatible version of Android, coming out with things like the CDD or CTS test suite to make sure that this manufacturer's devices would run Android applications the same as that manufacturer's devices. If you rewind and think about it, at the time, this wasn't important to anybody out there because each manufacturer had their own OS. They had many OSs. Each device might come out with a different OS, and it didn't matter. There weren't really app stores at the time. There wasn't really the need to run an application across different devices, even of the same manufacturer. And Android realized this is going to be huge for Android if we have a single ecosystem where all of these applications can live. So making sure that everybody understood that and could be compatible at that early stage was terribly important.
Another thing that was particularly important was timing. I love that in the book you interviewed a bunch of people and you asked everyone, why do you think Android did succeed? And I think they all, including myself, gave the same answer, which is we were at the right place at the right time, right? It was a lot of work and I think we did a lot of good things, but we also got really lucky with the timing. The fact is we were at an inflection point, in the market. The hardware was getting better. Touchscreens were making their way onto the scene. They were getting affordable. And there was the smartphones had already convinced users because they were popular, right? They were being sold, but they were not so popular that everybody had one. We saw the graph. The feature phones were still the major player in that market. So there was still room for something like Android or, for that matter, for iPhone to be successful. And then obviously there was the problem of Apple for other manufacturers. Once the iPhone came out, if you were, let's say, Motorola or Samsung, the question was, how do we compete with the iPhone? What do we have that's available right now in the next 6 months, in the next year, that will be just as good? And Android was the answer to that because we were targeting the same kind of capabilities, GPUs, large touchscreen, a vibrant ecosystem of applications.
Another Ficus quote. He should really He should pay us, or maybe he thinks we should pay him for all these lovely quotes.
Should be his job to just come up with quotes.
So this was the intro to the original edition of the book that came out last year. Anytime anything works out, if you don't acknowledge the huge luck factor, you're kind of a jerk, which to me, I think spells out things very clearly and honestly for the team that they did think that timing was a huge factor. Yes, the team did a lot of good things and worked really hard. On the other hand, they were lucky to be able to have that window of opportunity at the convergence of all the hardware capabilities and all the competitive forces that were coming to the world at that time.
And lucky that Google was interested, and lucky that Google acquired them, and lucky that everything went according more or less to plan. Like it could have failed in a million ways. Actually, that's the next book you should write. Like the million ways Android could have failed.
Yes,
that would be interesting.
All right, so let's take a step back. That's all the stuff that we want to talk about with Android history, as well as some of the things that we think contributed to the current success that Android has had. But what can we learn from this for general hardware, software, technology projects?
So the first one is the vision, right? You have to know what you're aiming for, and you have to carry through. So for Android, remember, like it started with an idea for digital cameras. It was an open source platform. And there was this big pivot where it didn't end up shipping for digital cameras, but for phones, because that was the core of the vision. The core of the vision was not necessarily like the hardware. It was getting users on that open source platform and creating a vibrant ecosystem. The other part of the vision, it's funny because we used to joke about that all the time. It's like, are we a product or are we a platform? Because we're kind of trying to work with hardware partners on designing a phone and a user experience while developing the platform. And the answer is that it was both, right? Like we wanted to showcase the capabilities of the platform with the product, and we also wanted a product to drive and inform what the platform should become eventually.
It's good to have focus on the team. So I talked about this earlier with having the team siloed and not getting distracted by all of the priorities of the larger company that they were within, but instead focusing on what Android needed to actually hit 1.0 and beyond. This not only kept them focused, but it also built loyalty to the project and the team and the colleagues and to the vision in a way that just being a part of a larger organization probably would not have.
Have the right people. It was interesting because, again, like Android had to go really fast, right? Like there were all those deadlines. There was a lot of pressure to be successful. And the idea was to find the people who would fit the project and not necessarily the company. And we alluded to that, but a lot of the folks, the early members of the team, had a ton of experience building operating systems. They knew the environment. They had built platforms. They had built ecosystems. And they were able to inform the project. And as a result, it went much, much faster than it could have otherwise. Of course, there's a drawback to that where, maybe new points of view for folks with a different experience could help shape the projects differently and come up with more innovation or whatever. But not everybody on the team came from the same background exactly, but we had all the experts that were needed. For instance, to work on graphics, we had graphics experts. For the Bluetooth stack, obviously, we had Bluetooth experts, although that was not always the case. I think some of us had to learn a few things on the job. But they were the right people because they were all focused, they were all marching in the same direction, they all wanted to be successful, and they were all helping each other get there.
So I alluded to this earlier when I was talking about open source. The ability for the team to ship an open source platform enabled the ecosystem to build in a way that it would not have otherwise. I talked to Diane Hackborn, who worked on the framework team, still works on the framework team years later. And she talked about her experience at PalmSource. PalmSource came from the original B team that then got acquired by Palm, spun out to PalmSource. They were working on an operating system. At that time, they were targeting it to mobile devices. They had a really hard time getting other companies to buy into that and to license their operating system from them because they didn't know what PalmSource was going to do. They didn't want to bet their company on some other company's vision. Open source took that out of the equation. We put the code out there, you do with it what you will, and that enabled all these partner companies to come in without all the trust issues that closed source systems have.
Another lesson we learned is that crunch times do happen, right? It was a tight team, so it enabled loyalty to the vision and to the rest of the team. There was this drive to succeed. There were all those constraints and those deadlines, so we had to work really hard, sometimes maybe too hard. And so, those crunch times happen, and honestly, I don't think that without them, like Android would have shipped when it shipped. But what's very important is to make sure that those those crunch times and death marches don't happen regularly and don't become part of the culture. At some point, they might have actually a little bit on Android. And then we spent a lot of time after that making sure they would disappear, because you should not do this in the long run, right? It was really about survival for the very first version. But after that, stop it. Don't crunch.
Competition is good in a couple of ways. One is, I do believe that it spawns innovation, like having somebody right beside you, right ahead of you, right behind you, makes you think, what can I do to make sure that I am still in this race next year, right? That's an awesome motivator for getting great features and capabilities in your product. But also, it is surprising how much it actually enabled Android. If we look at the iPhone launch, it's basically created the need for all of the other manufacturers not named Apple and all of the other carriers that Apple was not working with to have their own solution for a smartphone platform. They didn't have the software that they needed to launch these kinds of devices anytime soon, so they needed to look around and see who was available that they could work with so that they could come out with some competition for this new device and this new ecosystem that was building, and Android happened to be there.
And then, of course, you have to just keep going, right? Once you hit your very first version, your Android 1.0, you are not done. This is just the beginning. And that graph we saw earlier is a good example of that. I remember, when we were in the meeting room, cheering because we had sold 50,000 devices compared to the billion of devices that are out today. It's nothing, right? So we had to keep going. And for many, many years, there was still so much to build. I mentioned that we had to cut so many features from Android 1.0, so many APIs, so many tools. And then we spent a long time bringing those back, making sure that we would formulate the vision that we initially had when we started working on that project.
It's important to actually make forward progress. One of the things that the team was really good about early on was making pragmatic decisions and just moving. A lot of the decisions were made in architecture and design, in code implementation, in APIs. They were made because somebody sat down and typed out the solution. So there was some disagreement. There were people going back and forth. What should we do here? Somebody would go in a back room. Like I remember Joe Honorato basically wrote the first version of the toolkit in 24 hours. He was tired of people debating about what this thing should be. Instead, he just took some time, went away, wrote this thing, came back and said, okay, it's done, let's go. And now we can build on this. It ended up being refactored and rebuilt, but that didn't matter. At least having something in the sand gave everybody something that they could build on so that you could move from there. So another Ficus quote again that apparently we've licensed. While you're busy polishing it in the lab, somebody's going to come out with something and make you irrelevant. So I've been in so many projects where we spend so much time making things more beautiful, having API councils and debates and discussions, and they can go on and on and on. And that's great for the long term. But if in the short term you don't come out with anything, then the long term doesn't matter, right? So the ability to just go somewhere in a particular direction is key to actually making a project successful, at least in the beginning. Very important.
And timing, we talked about this already. You can't control the timing, but you have to be aware of what's happening, right? You have to understand your industry, your ecosystem, your competition, and you have to be able to react quickly in a tight window. A good example was, the T-Mobile G1 was always planned, but as soon as the iPhone was announced and launched, there was this big change that happened almost immediately to scrape the sooner and focus solely on Dream so that we could have something relevant by the time it came out. So it probably pushed back the release of the first piece of hardware by a little bit, but at least it was a device that was comparable. And that was very important, again, to the success of Android.
And of course, luck always counts. In particular, I want to point out that it's important to be humble and understand that I'm sure we're all awesome and we're all doing awesome things all the time. But maybe some amount of success in anything that we do is due to that luck factor that we cannot control. We can just appreciate it. But it's also true on the other side, which is maybe the projects that we're working on weren't successful. Most of the projects I worked on prior to Android weren't necessarily successful in such a large way. We could take some responsibility for that, but it's also important to realize that maybe the timing didn't work out for some of those technologies. And what do you do when something doesn't work? You just take a step back and you take a breath and you run and you do it again, because that's why we're here. We just keep trying.
All right, so real quick, before we end this talk, I wanted to talk about Jetpack Compose, because all the things that apply to Android can also apply to Jetpack Compose. So a good example is the vision, right? From the beginning, we wanted to build a new unbundled modern UI toolkit. The team was a little bit stuck, spinning their wheels, trying to figure out how we could build that. So there were many ideas going on, many ways you can build a UI toolkit, but the vision stayed the same, which was always to create this modern UI toolkit that was reactive and that would be unbundled.
The ability to focus, to remove distractions from that team at that time so that they could actually hone in on what was important, making that a priority for the people that were working on that instead of getting spun out into too many other threads that could thrash them in different directions.
People, so obviously we had a lot of folks who had worked on previous UI toolkits, if only because they worked on views, but we also hired a bunch of folks who came from other backgrounds, or some of them did not even have Android experience, and that was fantastic to get a new point of view, new ideas, things that we would have never thought about. And actually, to some level, Chet and I did not involve ourselves, on a technical level in the design of Compose, because we had one way of thinking. We had just spent 10, 12 years thinking about UI toolkits in one single way, and that would have been bad for Compose if we had, brought the same ideas back to the table.
It is important, I think, in technology in particular, or things with hard deadlines, to occasionally work hard. You could accept the fact that there may be crunch times, but the team certainly had that. But as long as they are confined to, we've got to hit this release for a particular timing thing, everybody's sort of focused and heads down doing that thing. But it was not as insane as pre 1.0, nor was it unlimited, which was also kind of true of those early days. But occasionally crunch times come up, and it is a factor in getting things out at the time when the users need them.
And competition is really good. The existing UI toolkit for Android, the Vue system, was over 15 years old when we started working on Compose. And in the meantime, a lot of competition showed up, right? A lot of those new frameworks. So for instance, frameworks like React or React Native with this new way of building UIs. And it was amazing because it showed us a new way, a better way of building a UI toolkit. And we heard loud and clear from developers that they preferred that way. So it was a great opportunity for us to rethink our approach to UI development on Android. And without competition, it's not guaranteed that we would have got to that point ourselves.
It's important to ship something. So I remember aspects in 1.0. You told me about how the engineering director would cut features coming up toward the end because the date was more important than any specific feature. And the same thing was happening in Compose. Coming up to 1.0, it was going to be hard to hit that date. It was going to be impossible to hit that date. And so as you get closer, it's important to cut the features that you can so that you can keep the date and then move on to future versions after that.
Keep going. That one is an easy one. About a year ago, we shipped Compose 1.0. Well, we're not done, right? We had to cut a lot of features to be able to get there. So now we'll still have many more releases ahead of us. We're not done. We're not going to be satisfied until our developers are, 100% happy.
Timing was, of course, important for Compose. I think Romain alluded to some of this with the popularity of reactive programming, the popularity of the Kotlin language, and how we could build on that, and some of the new ideas that came in for this toolkit. So we sort of were able to hit the market of users and developers at a time when all of these things were something that they wanted to use anyway.
And timing for us as well, right? Like Kotlin enabled us to do some of the things we do with Jetpack Compose. And without Kotlin, I'm sure we could have created something like Jetpack Compose, but maybe not as good. Yeah. So, we got lucky there. And we're not going to go into details because, again, there are many reasons why Compose could have failed. There was an element of luck involved. And that's it for today.
I think so.
Yeah, thank you.
That will do. Thanks.